here we go. So let's start looking at learning how to do statistics. Now that is one of the important mathematics out there. I mean, I'm going to tell you, this is one of the hardest type of field that ever be going on out there, because, I mean, look at everything around you. It's all about statistics. Any kind of conclusion that you need to make, it's all based on statistics. It's all based on these data here. So you are today learning about how to do statistics. Alright, so now here we go. So before I start, my first expectation for you is more or less, it's more like my advice for you. Pretend that you are now a professional, serious statistician, that you're working with serious data. Even though these examples that we might be doing in these lessons here are small, somehow small, compared to the real one out there in the real field, but think about it. I mean, who knows, someday some of you, one of you or some of you are going to be a real statistician, and the real data set later on you're going to be working at, it's going to be much larger than these data sets we're working now. However, it's still going to be the same sort of technique, the exact same number of techniques that you're learning today going to be applied into those days in the future that you're going to be working with the real statistics. All right, so now, first, statistics is about studying data, right? Once again, as I mentioned earlier, the world around you is all about data. I mean, whatever that you're trying to make a conclusion on, whatsoever, you always need some sort of data to back up your conclusion. That is your proof. That is your evidential support. So statistics here is about we're studying data. Okay. So now we'll be just using the two data sets for our entire lesson here. I mean, we don't need to go more than that, because believe me, just two data sets are good enough. Okay. So my data set number one here is the following table. As you can see. Now, this table here has about, let's say, 40 items, right? 40 different data values in that. And you can see that, notice so far on this table over here, the data values, I mean, some of the rows and the columns are colored. However, they're just all over. I mean, the values here are just all scattered. They're not sorted out or anything like that. They're just random values, okay? And so now, we got about 40 data values, right? The next data set that we have here, I call it data set number 2, is a list of numbers. And once again, these are the list of values. And so, I mean, talking about data sets, you can think of these data sets, you can pretend that these data sets we're working with, they could be like exam score, or they could be like ages, right, of a certain community, right? Or they could be some certain of like degree levels, like cholesterol level, for example. I mean, it could be anything, right? So once again we're having these two data sets, right? And so we will be learning the statistic techniques or the statistic mathematics based on these two data sets right here throughout the whole lessons. All right. So now, first off, most importantly, it's not a rule. However, it's always extremely helpful to sort out your data sets in increasing order. So the highlight here is that, set your data set sort it out in increasing order. I mean, it's, like I said earlier, it's not a rule, but then it's extremely helpful. Okay? So now, in the way how it should be, my two data sets here, our two data sets that we're going to be working with. Data set 1, after you sorting it out, you're going to create for yourself a list, right? 40 items, 40 data values, and then here we go. Imagine, this is a video lesson, so you don't have to, you can pause the video lesson right now and, really try to sort out the data set for yourself. It took my student in the other class over 10 minutes to sort out this data, okay? The whole reason I'm making you do this, I really want you to pause the video and spend some time sort out the data set yourself. The reason here is I would like you to have a real taste of how statisticians in the past actually got their work done without these computers around them these days. Okay? These days here, no matter how large the data set is, we have the computers, we have Microsoft Excel, we have all those spreadsheets program can get these sorting out works done for you in no time, quickly, in no time. But imagine 20 years ago when statisticians, they're working on just pencils and paper, then how much time can you imagine how much time they have to spend on these data sets to just simply sort it out? So, I mean, I just want to, to introduce you to some of the real feeling of the real statistician working out there on the real field. So now, with my data set 2, after we sort it out, it's going to be a list like that. And then probably what you have noticed so far throughout my 2 data sets here, you can see that it's okay to have values to be duplicated. Now you can see obviously let's say my value 76 value right here, there are 3 of them. It's okay for data values to be repeated. I mean, imagine, it could be more than one person being at the same age in the whole community, right? I mean, it could be, I live in the Lake City community right here, and, it could be more than one person being at the same age with me. So if we're looking at age as a data set, then, it could be more than one people with the same age, right? So once again, it's not a surprise to have more than one data values in the data set, okay? And the data sets, they don't have to be distinct. So what I can see in my data set, right, number 2, I got 3 values for 2, 5 values for 3, right? 5, 3 values, and then 1, 5, 1, 6, and 2, 7, right? Things like that, on and on, right? And so now, the first thing that we need to learn on the data set. So how about we focus on data set number 1 right here. Data set number 1 after we sort it out, okay? So in my data set number 1, when we sort it out, then let's say this is the idea right here. Let's see what we're going to be doing with that. The first thing we can do with the data set is we need to somehow get a visual display of how the general data set looks like. So what we need to learn here is how to make we need to create a what's so-called frequency distribution table. Okay? We need to learn how to be able to create for ourselves a frequency distribution table. Alright, so now what's up with this idea? The whole point now is that create for yourself a table. 2 rows. I mean, it doesn't have to be rows, but 2 rows, right? The textbook, they're using 2 columns, but it's okay. Rows or columns, doesn't matter. The point now is that on the first row, you're going to start listing out those distinct data values. So what I'm saying here is that, say, looking in your data sets, right? Let's say for 43, right? 43 is my lowest. If you're looking back at the data set, right? 43 is the lowest data value that I found, so I write down 43 in my first row of the table, and I draw a column there. Now, what I noticed that how many 43s are there in my data set? 1. There's only 1 of them. So, down in the bottom row, right below 43, I write 1. So once again, what does 1 mean? 1 here means it is the number of times that the data value 43 happens. Okay? So now, moving on, after 43, what I see is a 45, right? And once again, how many 45s are there? There's only 1. There's only 1, so I'm going to write it down. There's just 1 in the bottom. Right? So once again, the bottom line here is that for this frequency, see, so once again, why is it called frequency? Because the number 1 right here represents the number of times that 43 happens, right? So that's why, 1 here is like the frequency, how often, how frequently the data value 43 occurs, right? And likewise here for 45, 1 is the frequency for 45, right? So on the top row right here, I can just simply label that S, which represents for data, right? Okay, and then at the bottom here, it's just the frequency. I call it F. Okay, so F represents for the frequency. Now, so you can continue on with this table. Now, next I have 47, right? And once again, you can see that there's only 1, right? And then for 50, there's only 1 again, right? And you can continue on with your table, keep going on. And then, let's say, on the same data set, right? Let's say 66. How many 66 are there? There are 2 of them, right? So I'm going to write 2 this time. Okay, I'm gonna write 2 for 66. Now the dot in between here means, you know, you can continue the work here. I'm a little short in space, so I'm not gonna write it all out, right? But then when you're working this on your own sheet of paper, on your own notes, right? Make sure you fill it in, right? I mean, what I mean here is beyond 50, you have 54, you got 56, and 57, okay? And then 66, there are 2 of them. And also what I can see is like furthermore when I reach to like, let's say 76, there are 3 of them. Okay? And of course your table will not stop right there. Your table can continue growing further until you reach to the very last distinct data value. Okay? So that's the idea of a frequency distribution table. Okay? So now what can we do with this frequency